Mazda just brought back an engine every automaker on the planet pronounced dead in 2012. Not as a tribute badge, they built it into a 365 horsepower EV concept. 11 years buried, guys, and the part that made me stop scrolling isn't the horsepower. It's who's doing this. So why is Mazda of all companies making this much noise right now? Because that's the twist. This is the same Mazda that usually just quietly ships something and lets the driving experience speak for itself. When Mazda goes loud, that's the signal to pay attention, not the noise to tune out. Before we get into it, make sure to subscribe to the channel so you can watch videos like this before anyone else. Range extender EVs have quietly been the sleeper story of this decade, not the headline battery breakthroughs everybody keeps chasing. Mazda just handed this whole idea a pretty good receipt. So here's what we're doing today. We're going to go back and figure out why this specific company was basically the only one on the planet that could pull this off. We're going to get into the actual engineering of how a 50-year-old rotary design turned into an EV generator. And this is the part that matters to your driveway. What it means for the price and the range anxiety on the next car you actually buy, whether that's a Mazda or not. If that's useful to you, hit like. It genuinely helps the algorithm put this in front of more people who are on the fence. About EVs. Let's get into it. To actually understand why this announcement landed the way it did, you've got to go back to where this company came from. Because Mazda's whole identity was basically built by making the one bet nobody else wanted to make. Mazda started in 1920 in Hiroshima, and it wasn't even a car company at first. It was making cork products and machine tools. I know, weird starting point. By 1931, they'd built their first vehicle, the Mazda Go, which was this tiny three-wheeled truck, nothing glamorous, but it got them into the automobile business. Now here's the part that actually matters for today's story. After World War II, Hiroshima was basically flattened. Mazda was rebuilding from a city that had just been through the worst industrial devastation in human history, and instead of playing it safe and just building whatever piston engine everybody else was building, the company went out in the 1960s and licensed rotary engine technology that most of the big automakers had already looked at and passed on. Companies like GM, like Mercedes, they poked at it and walked away. The problem was real. Rotary engines burned fuel less completely than a piston engine, which tanked fuel economy, and the apex seals, the little components that keep the rotor sealed against the housing, wore out under the heat. Most companies looked at that math and said not worth it. Mazda didn't walk away. And in 1967, they launched the Cosmo Sport, which was basically Mazda standing up in front of the entire auto industry and saying, "We made this thing work when you all said it couldn't." That's the moment the rotary engine becomes Mazda's identity. Not just a product line. It shows up in the RX series after that, and by the time you get to cars like the RX-7 and the RX-8, this engine has this whole cult following. The sound, the way it revs, the fact that it's compact enough that people used to describe it as being roughly the size of a watermelon sitting under the hood. Plenty of owners describe the same thing. Pop the hood on an RX-8 at any car meet, and people are still surprised by how much empty space sits around that little engine. That's the kind of detail that turns owners into lifers. But emissions regulations kept tightening. Fuel economy standards kept climbing, and the rotary's old weaknesses never fully went away. Production of the RX-8 ended in 2012, and for most of the industry, that was it. Story over. A 50-year experiment that had a great run and then died the way most niche engineering ideas die. Quietly, with enthusiasts mourning it on forums. And most industry watchers bought into that ending too. For years, all the end-of-an-era pieces treated it like a closed chapter. Everybody moves on to hybrids and batteries now. Which, to be fair, is exactly what most of the rest of the industry did in that decade. Toyota doubled down on hybrids. GM and everybody else started throwing money at bigger and bigger lithium-ion packs. Nobody was sitting around in 2013 thinking the rotary engine had a second act left in it. Mazda's engineers, apparently, were the exception, and they were working on it quietly, in the background, for basically a decade, while the rest of the industry assumed the story was closed. Except Mazda's engineers never actually stopped working on it. That's the root cause of everything we're about to talk about, so let me just say it plainly. Mazda decided the rotary engine's job description could change even if the hardware stayed rotary. Instead of asking, how do we make this engine drive the wheels better, they asked, does this engine even need to drive the wheels at all? That single reframe, decoupling the rotary from propulsion and turning it into a pure electricity generator, is the whole reason this technology is back in headlines instead of staying a museum piece. That idea comes back a few more times because it's the spine of literally every decision Mazda has made since. So let's actually get into the mechanism, because this is the part most coverage skips past. And it's honestly the most interesting part. In a normal piston engine, you've got pistons moving up and down, converting that linear motion into rotation through a crankshaft. Lots of moving parts, lots of vibration to manage. A rotary engine skips that conversion step entirely. There's a triangular rotor that spins directly inside a specially shaped housing, and as it spins, it's drawing in the air-fuel mixture, compressing it, igniting it, and pushing it back out, all in one continuous rotating motion instead of pistons slamming up and down. Fewer moving parts, way more compact packaging, and it can rev to a completely different character than a piston engine. Now here's what that means for you sitting in the car. In the new MX-30R EVE, that rotary engine does not touch the wheels, at all. The wheels are driven 100% by an electric motor, all the time, so the car drives like a pure EV from the driver's seat every single time you're in it. The rotary's only job is that when the battery gets low, it fires up, spins at a steady, efficient RPM, instead of constantly changing speeds like it would if it were actually propelling the car. And it generates electricity to feed the battery. That steady-state operation is a big deal, because a huge chunk of the rotary's old reliability problems came from constantly changing loads and speeds. Run it at one efficient band instead, and a lot of that old apex seal stress just goes away. Mazda didn't stop at just changing the engine's job description either. They went back into the actual hardware and rebuilt several of the parts that used to fail. Direct injection is the first one. In the old rotary, fuel got sprayed in a way that meant some of it never fully burned, which is a big part of why fuel economy always looked bad on paper. Deliver the fuel more precisely into the combustion chamber, and you burn more of what you put in. They also redesigned the cooling channels and improved the airflow around the engine, because heat was always the rotary's other enemy. High temperatures stress basically every internal component, and the apex seals, Mazda's using new materials and a diamond-like carbon coating, DLC coating, on the surfaces that see the most friction, the same kind of coating you'll find in other high-performance industrial applications, specifically to make those seals wear out slower. None of that is a full rewrite of physics. It's Mazda going back through 50 years of known complaints, one at a time, and engineering around each one. And that brings us to the thing that actually forced this video, because Mazda didn't just dust off the old design and slap it in a car. Look at the actual spec sheet on the MX-30R EV. It's running an 830cc single-rotor engine, 0.83 of a liter, which for comparison is smaller than most motorcycle engines, paired with a 17.8 kilowatt-hour battery, which is small on purpose, and Mazda's own numbers put electric-only range around 53 miles, 85 kilometers, before that rotary generator ever needs to wake up. But here's the number that actually matters. Total range, once you count the rotary topping the battery back up using a 50-liter fuel tank, lands north of 600 kilometers, close to 370-something miles depending on which region's testing cycle you're looking at. That's a car that drives like an EV for basically every commute you'll ever do, and then just doesn't stop on the road trip. The electric motor itself is putting out around 125 kilowatts, that's about 170 horsepower, and the little rotary generator is contributing somewhere around 55 kilowatts, roughly 74 horsepower, just quietly making electrons in the background. That was supposed to be the ceiling for what a 50-year-old engine architecture could still contribute in 2026. It wasn't. Because a few years back, Mazda rolled out something that made the MX-30R EVE look almost conservative, the iconic SP concept. This is a two-rotor version of the same philosophy, shown off at Japan's big mobility show, and reports out of that reveal put combined output somewhere around 365 horsepower, with Mazda talking about a 0 to 60 in the mid 5-second range as a target, on a rotary range extender platform. Let that sink in for a second. The same basic idea that's putting out 74 horsepower in a small crossover is the same basic idea Mazda is using to chase supercar-adjacent numbers in a concept sports coupe. That's not a party trick anymore, guys. That's a company telling you this architecture scales. The iconic SP was still a concept car when it was shown, not a car you could walk into a dealership and order, and that's worth being straight about, because some of the coverage out there kind of blurs that line. But Mazda's own engineers and executives have talked about the iconic SP's rotary generator layout as a genuine preview of a future production sports car architecture. Not just a design studio fantasy that gets shelved after the auto show lights go off. That's a meaningfully different signal than most concept cars send. And here's where it escalates one more time, because Mazda isn't stopping at gasoline. The company has filed patents around a hydrogen-fueled version of this same rotary generator setup, and they've actually demonstrated hydrogen rotary prototypes based on the CX-5 platform, going back a few years before that. The idea, and genuinely a clever one, is that you don't need to design a whole new vehicle architecture for a whole new fuel. If the rotary's only job is spinning a generator, you can theoretically swap what's feeding that generator, gasoline today, hydrogen down the road, without reinventing the car underneath it. Japan's been pouring money into hydrogen infrastructure for years. Germany's been building it out for heavy transport. South Korea's got national hydrogen initiatives running. And parts of the Middle East are investing heavily in green hydrogen production for export. The infrastructure side is still genuinely early. We're talking a small fraction of the refueling stations that gasoline or EV charging has. So this is a future bet, not a today product. But it tells you Mazda is thinking about this rotary generator as a platform, not a one-off gimmick for one crossover. Now, the honest objection, because this doesn't solve everything, the MX-30 REV, as of right now, isn't even sold in the United States. It's a European and Japanese market car. So if you're watching this from the US wondering when you can buy one, right now you can't. And Mazda hasn't given a firm date for bringing this exact powertrain stateside. And the rotary's original sin, the fuel efficiency problem, hasn't magically disappeared just because it's not driving the wheels anymore. It's just being asked to do a smaller, more forgiving job. There's also the reliability question that's dogged this engine for 50 years. Mazda says the new Apex Seal materials and the diamond-like carbon coatings on high-friction parts fix the durability issues that killed the old rotary. Says, we genuinely will not know if that's true until these things have a few 100,000 collective miles on them, out in the real world, not on a press event loop. There's no good answer for that one yet, and honestly, neither does Mazda have one. Not really, not until the data comes in over the next few years. And on top of that, this whole strategy only makes sense in markets where the charging network still has real gaps. Dense EV charging countries like the Netherlands honestly need a range extender a lot less than a driver out in a rural stretch of Germany, or frankly, most of the United States outside the coasts. So the same feature that's a selling point in one region might barely matter in another, which makes this a harder story for Mazda to tell with one single global marketing pitch. That's a real limitation, not a small one, and Mazda hasn't fully solved the messaging problem there yet either. So here's why any of this actually matters to you, even if you never buy a Mazda in your life. Every automaker watching this, Toyota, GM, even the EV-only companies, is watching to see whether a range extender genuinely kills the number of buyers give for not going electric, which is, what if I run out of charge on a road trip and there's nothing around? If a small, efficient generator bolted onto a mostly electric car proves out in the real world that pressure pushes every manufacturer towards smaller, cheaper batteries, paired with some kind of backup generator, instead of the industry-wide arms race toward bigger and more expensive battery packs. Smaller batteries mean less lithium, less nickel, less cobalt demand, which pushes prices down across the board, not just for Mazda buyers. That's the actual mechanism here, and it's worth remembering the next time somebody tells you the only path forward is a bigger battery. Think about what a 17.8 kilowatt-hour battery actually costs to build, compared to the 75, 80, even 100 kilowatt-hour packs some of these long-range SUVs are hauling around now. You're talking about a fraction of the raw materials, a fraction of the weight sitting over the axles, and a pack that size can theoretically be manufactured a lot cheaper and a lot faster than the giant packs everybody's been racing to build. If range extenders like this one actually catch on, in volume, that's downward pressure on entry-level EV pricing across the board. Mazda badge or not, because every other manufacturer's battery supplier suddenly has more competition for a smaller, cheaper category of pack. That's the kind of thing that shows up 2 or 3 years later as a lower sticker price on whatever you're cross-shopping, and most buyers will never even know why. And that's really the law underneath this whole story. Battery size was never the actual constraint on EV adoption. Confidence was. Mazda didn't win by out-engineering Tesla's battery chemistry or out-manufacturing BYD's scale. They won a news cycle by solving a psychological problem with a 50-year-old idea nobody else was willing to dust off. Expertise compounds, but it also erodes, and you can't just buy it back overnight. Mazda gets to have this moment because engineers kept a 50-year-old idea alive through a decade where literally nobody was asking them to. A company that walked away from the Rotary in 2012 and never touched it again would not be able to show up in 2026 with a working range extender and a 365 horsepower concept, built on the same architecture. That patience is the actual asset here, more than the engine itself. So here's the actual question, and drop your honest answer below in the comments. Is this the smartest use of a legacy technology from a legacy automaker in years? A genuine third path between pure EVs and pure gas that other companies are going to be forced to copy? Or is this a clever nostalgia play from a company that knows its fanbase loves the rotary sound, dressed up in electric vehicle language to get headlines it wouldn't otherwise get? There are real arguments on both sides here, and it's honestly not a settled call yet. Next week's video goes through which battery chemistries are actually sitting in the EVs on US lots right now, pack by pack, because that story's just as messy as this one.